Thank you. Uh, as you mentioned, my name is Jeff Kehres. I'm a senior software developer at Research in Motion. And today I'm going to be talking to you about BlackBerry 10 and how Qt fits into our architecture. So today I'm going to talk about three key areas. So first I'm going to talk about some key events that influenced the development of BlackBerry 10. Then we're going to do kind of a walkthrough of the BlackBerry 10 platform and talk about some of its APIs and specifically focusing on where Qt fits into that architecture. And finally, we're going to wrap up with a talk about the future. So some of the things that we're doing and ways in which we can collaborate better with the Qt community. So let's first talk a little bit about a brief history of BlackBerry 10, kind of give you some events in the timeline of its development to kind of help you appreciate maybe why we made certain choices. So it was announced just the other day that BlackBerry 10 is officially launching January 30th, 2010, so in a few short weeks. But obviously it was in development for much longer than that. So let's roll back the clock about 3 years and talk about the beginning. So prior to BlackBerry 10, RIM had an operating system that was based on a kernel that we had developed in-house, and it was there was a Java virtual machine which we had developed in-house, and all the apps were written in Java. But this platform was showing its age, and it was becoming clear that it wasn't going to be able to scale to meet the needs of the new devices that we wanted to have coming in the future. So the decision was made to start over and build a new operating system from scratch. So some of the requirements for our new operating system were that we wanted to have a really solid and secure kernel at the foundation. In particular, we wanted support for multi-core processors because we knew that those were coming on our hardware vendors' roadmaps. We wanted to build our platform using open standards and open technologies to make sure that we weren't reinventing the wheel where we didn't have to be, and to make sure that we were interoperable with other platforms when it was practical. We wanted to have a great experience for our developers, so that means if you had an application written for another platform, that would be easy to move it to BlackBerry 10. And if you were starting from scratch in BlackBerry 10, you would have a lot of really nice APIs and frameworks and tools to work with to make your life easier. Uh, RIM was entering both the tablet market, and we already had a presence in the smartphone market, and we didn't want to have an operating system for every kind of device. So we needed the one OS that would serve many hardware platforms. And finally, we wanted our users to have great experiences using BlackBerry 10 devices. So we wanted really great performance, and we wanted to enable really slick user interfaces on BlackBerry 10. So the first thing that kind of got the ball rolling was in spring of 2010, we acquired a company called QNX. And using the technology from QNX, we developed the first BlackBerry tablet called the Playbook, which was released in the spring of 2011. And then the second version of the tablet OS for the Playbook was released early 2012. So what do we get from QNX? So QNX gave us a really awesome real-time operating system. It's used in a lot of different markets, from cars to nuclear power plants. Uh, it was designed for embedded systems, so it could run on very resource-limited devices, but it could also scale very well. So it could support multi-core systems, multi-processor systems, even systems of network machines. Uh, it uses POSIX standard, so all of its APIs would be very familiar to you if you come from a Unix or Linux background. And it's also very secure and very safe, and it has certifications to back up those claims. So it's kind of meeting that first requirement of having a rock solid kernel to build our new OS on. And as I already mentioned, it was the foundation for the BlackBerry Tablet OS, which was used for the BlackBerry Playbook. And this OS is really the ancestor of BlackBerry 10. A lot of the technologies that were developed for the tablet OS are also present in BlackBerry 10. So next, in December of 2010, we acquired a company called TAT, based in Sweden, in Malmo. TAT stands for the Astonishing Tribe. This is a team of very talented UI designers and software developers that work very closely together. They've made some really amazing user interfaces for various big companies in the mobile space. You can go on YouTube and they have a number of cool kind of prototype videos that they've made to kind of show off their design chops. And most of the work that they've done for their clients was built on their own UI engine, which they developed that runs in OpenGL. And on top of that, they had a declarative UI framework. So with the acquisition of Qnix and TAT, we had kind of a UI stack and we had an OS kernel, but we kind of needed to fill in the middle. And so that's where Qt entered the picture in the summer of 2011. So Qt on Qnix originally started as a side project. I started it. Uh, my activities on BlackBerry 7, which was our previous OS, were kind of winding down, and I was looking for something interesting to work on, so I thought it'd be cool to have Qt running on Qnix. So first I looked and I wanted to see if there was already a port of Qt available for Qnix, and there was, but it was based on Qt embedded, and that really wasn't what I wanted because I wanted to integrate with the windowing system available on Qnix, and Qt embedded has its own windowing system. Fortunately, this time Qt4.7, a technical preview had just been made available, which introduced the Lighthouse project, which has now been rebranded as the Qt Platform Abstraction Layer, or QPA. And this was really what I was looking for because it allows Qt GUI to very nicely integrate with a host windowing system. It's a very nice abstraction layer. So importing Qt to Qnix, Qt4.7, there were two major tasks. One was cross-compiling Qt, so it would run on Qnix. So this involved figuring out the Qnix toolchain. It involved figuring out the Qt build system, Qmake, and all things like that. And then it also involved writing a QPA plugin. So this is the plugin that integrates Qt GUI with the Qnix windowing system. Now, outside of the QPA plugin, because QPA plugin only covers the graphical interface between Qt and a host operating system, we use the standard Unix backend for many classes because, again, Qnix is a POSIX-based OS, so many of those backends just work out of the box. So in parallel to this project that I was working on, RIM was searching for the right development language that we should be using for applications. Should we be using Python or Java or C++? And we were converging on C++, and we were looking at various frameworks to use with C++. And so my work kind of just happened to pop up at the right time. And the rest is history. So today on BlackBerry, we have a dedicated team within RIM for maintaining Qt. They're based here in Germany. Many of them are sitting here in the audience. And we also partnered with the consultants at KDAB. And together we've been further improving and adding features to our port of Qt. Our port of Qt runs on all the Qnix-based OSs that RIM has developed. So this is version 1 and 2 of our OS for the playbook and for BlackBerry 10. We have ports of Qt4.8 and Qt5. The Qt5 port is probably experimental at this point because 5 hasn't officially been released. And more of our energy has probably been focused on the Qt4.8 port because we're going to be shipping Qt4.8 on BlackBerry 10. And all of the work we've done to port Qt to our platform has been upstreamed. So you can visit the official Git repo for Qt if you want to check out what we've done. And on the Qt project site, we have a wiki page for BlackBerry, which has instructions on how to build both 4.8 and 5.0 if you want to play around with source code. So with those three major pieces, the OS, the UI stack, and application framework, we had kind of the major pieces and beginnings of BlackBerry 10. And in May of 2012, we released our first beta SDK for BlackBerry 10. That was also when we made available our dev alpha hardware, which is a prototype hardware that developers can use to test their app That's very similar to what the final BlackBerry 10 hardware is going to be. And we've been making regular releases every month or so since then. And in October of this year, App World opened and began accepting submissions for BlackBerry 10 apps. And at that point, we made a guarantee of binary compatibility with our APIs. So when our final Gold SDK is released, which I believe is about the end of the year, um, your app will be compatible if it was, since October. So that's just a few key things that happened over the past few years, which influenced the architecture and the design of BlackBerry 10. So now let's do a walkthrough of BlackBerry 10 and kind of show you what it's all about. So first of all, if you remember from the requirements, we wanted our developers to have a really great experience and make it easy for them to write apps for BlackBerry 10. So one of the ways in which we've done that is we've given you choice. So there are four major pillars that you can use for application development. You can develop an application using HTML, JavaScript, and CSS, and build on our WebWorks framework for accessing BlackBerry services. You can write a native application using C, C++, and Qt. You can write an Adobe Air app in ActionScript, and we have extensions there for accessing BlackBerry services. Or if you have an Android app, you can port it to BlackBerry 10 quite easily, essentially to repackage it, and you can run it in an Android player we have for BlackBerry 10. But this is the Qt conference, so let's talk more about native application development. So this diagram here kind of shows some of the major layers that make up our native platform. So at the bottom here, we have QNX operating system. We have its POSIX APIs and also some QNX-specific extensions which they've created. We have open standards like EGL and OpenGL for doing graphics. And we also have some C APIs which we've added for accessing BlackBerry-specific services. On top of that, we have a number of helper libraries, useful libraries that you can use to write your application. Many of these are open source ports or open source libraries that we've ported. So we've got things like SQLite and CouchDB for database access, Zebra Crossing for barcode detection, Box2D and the Bullet Physics library for physics engines if you're developing a game. If you're doing game development, we have a number of popular game engines ported, like the Unreal Engine, Marmalade, and Unity. If you're not doing game development, then we have a really nice application framework in C++ that's built on Qt. So we have all of the Qt libraries that you would typically expect in a port. And then on top of that, we have a set of libraries we've developed that we call the Cascades Framework. And these are for accessing various BlackBerry specific services. And the Cascades framework contains the UI technology that we acquired from TAT. And one thing to point out here is that that technology, while it builds on Qt, is not compatible with Qt GUI. So if you're writing an application, you just need to, early on in your development, make the decision, am I going to write a pure Qt app and use Qt Quick and Qt GUI, or am I going to use the UI framework that's available in Cascades? So let's briefly touch a little bit more on Cascades, but if you want to know all the details, you can go tomorrow morning to another talk which is going to dive into it in great detail. But just quickly at a high level, so what is the Cascades UI framework bias? Well, we want BlackBerry apps to have a very particular look and feel, and we want the UI interactions to behave in a very certain way. So what we did was bake that look and feel and that behavior into our UI framework. So if you use our stock controls, all of the apps will be consistent. The back end that's used to power Cascades has been heavily optimized for BlackBerry hardware. So we're using the GPU to hardware accelerate everything. And one interesting architectural note is that all the rendering and animations occur on their own thread. So if you happen to block the main thread of your application, your app will still appear responsive to a degree. We support both C++ API for developing your UI in Cascades, the Cascades UI framework, and a QML interface. So if you have familiarity with Qt Quick, it'll seem very familiar to you. And again, just wanted to point out that while we do build on Qt, we Cascades UI Framework doesn't build on QtGUI and QtQuick. So here's a quick example of Hello World at the top, showing you how to do that in QtQuick. On the bottom, showing you how to do that in Cascades. Really simple app that basically just loads a QML file. I'm not really going to talk about this too much, just wanted to highlight one point, which was when you're writing a QtQuick app or a QtGUI app, you're going to be using the Q application class, which derives from QCore application. If you're developing a Cascades application, we have our own application class, which also derives from QCore applications. So again, just be aware that QtGUI doesn't work with Cascades. So if you want to see what the QML looks like, at the top is Hello World in QtQuick. In the center section there is Hello World with Cascades. And in the bottom is Hello World with the C++ APIs, or the C++ version of the same Cascades UI. So if you do choose to use Cascades, the UI framework, as the foundation for your application, this pie chart shows where the APIs that are available to you come from. So you can see about 50% of the APIs that you use to develop a Cascades based application come from Qt. So these are all of the non-UI, non-QtGUI dependent libraries. Of the libraries that RIM wrote, the other 50%, a little more than half are UI related APIs. And then the remainder are our non-UI related APIs for accessing BlackBerry services. So if you're writing a QtGUI or QtQuick app, obviously you can use all the Qt libraries, so both the UI and non-UI related libraries, and you can use this dark purple wedge as well if you wanted to integrate more deeply with the BlackBerry platform. So what do you get on BlackBerry 10 with regards to Qt libraries? So again, we're shipping Qt 4.8 because this is what was stable and available when we started our development. So these are all the libraries that are available on device. I put an asterisk next to each one, which depends on QtGUI. So again, if you're building a Cascades UI application, just be aware of those dependencies. Some of those libraries contain APIs which don't depend on QtGUI, which you can use just fine. So besides kind of the standard libraries that are part of the Qt project, we also used a few libraries from Qt Mobility. So Qt Multimedia Kit and Qt Sensors are available stock. Qt Location and Qt Connectivity are a slightly different story. We took some of the APIs, but not all of the APIs. And so we created two new libraries called Qt Location Subset and Qt NFC Subset. I'm going to talk about those in the next two slides. And finally, from Qt Labs, there was a class called QCollator for alphabetizing a list of strings in a locale-sensitive way. And that class we took and put in its own library called libQtCollator. So Qt Location Subset is based on Qt Location, but we removed the landmarks API because BlackBerry has its own system for dealing with kind of a database of points of interest. It's called the Places API. And we removed the mapping and routing APIs because those were dependent on QtGUI. So what's left is positioning and geocoding. Geocoding is translating to and from or between a coordinate and an address, for instance. We also removed the geofencing API because its design caused an inefficient use of the GPS. We also borrowed a feature from Qt 5 in QGeoAddress and backported it. And then we exposed a few extra settings via objects that are returned from a factory, where the subclasses that we return have extra properties that you can use the QMeta object system to access and set them. So this allowed us to extend those classes without actually changing the signature of those classes. Because we may at some day have a full version of Qt Location, to avoid naming conflicts, we put everything in a namespace called Qt Mobility Subset. And actually just yesterday, we got the source posted on our GitHub website. So you can go check it out if you want to see the source for that. Qt NFC Subset is kind of a similar story. where we started with Qt connectivity. We want to have a full port of Qt connectivity. We have plans to deliver a full port, but given our timelines, there simply wasn't enough time and enough resources to get it done. So instead, we took the APIs which kind of were essential for the BlackBerry 10 launch, and we pulled them into their own library. So we have only the parts, only the NFC API from Qt connectivity, and of that, only the API for encoding and decoding NDEF messages. We did make an addition though. We added support for smart poster records. So this is if you have got an NFC phone and for instance you tap a product display or a poster that has a smart tag embedded in it. That's what those additions are for. And we also fixed a bug in the binary message format of NDEF messages. And I believe we're actually working on upstreaming those changes to Qt connectivity. Yep. Again, we threw it all in its own namespace to avoid conflicts when Qt connectivity rolls around, and it's available on our GitHub website. So now let's talk about the libraries which RIM added that are built on top of Qt. So first we have libbb, which is similar to Qt core in that it contains very low-level services and a lot of other libraries build on top of it. BB data contains APIs for loading JSON data, XML data, or loading data from a SQL database. And we use this library to do data binding with our UI elements that are data driven. So for instance, you can have a list pulling data automatically from a SQL database. BB device contains APIs for getting information about your hardware. So you can get information like the current battery level, what cellular networks you're connected to, what the pin of your BlackBerry is. BB multimedia contains APIs for playing and recording audio and for playing back video. And it's in this non-UI category because to play back video, you simply need to provide the handle of your QNX or the QNX handle of your window, and the video will appear there. It's not dependent on any particular UI framework. BB network contains APIs for doing push notifications. BB PIM contains our APIs for accessing messaging, so email and text messages, accessing contacts, accessing calendar. BB platform contains APIs for accessing high-level BlackBerry services. So you can do things like payment processing within your app. You can show notifications on the device. BB platform BBM is for integrating with a BlackBerry Messenger, which is a very popular chat service available on BlackBerry. BB system is for accessing lower level services, BlackBerry specific services. So here you can access like the phone, and you can access the clipboard, and you can access our Invoke framework, which is a system for launching another application or having another application create some UI that your application then hosts. So it allows you kind of very deeply integrate functionality between apps. BB Utility has some miscellaneous things like a spell check API, and BB Utility I18N is some helpers for doing internationalization, so doing like string formatting in a localized way, and it uses the ICU libraries to do all of its work. So the UI related libraries we've created start with BB Cascades. This is the big one, like Qt GUI. Most of the core functionality lives here. So we've got core components, we've got layout managers, animations, we've got WebKit integration here, so for a web view. BB Cascades advertisement, as you might guess, is for doing advertising within your app, like banner ads. BB Cascades Maps, again, it's probably pretty obvious. It's got UI elements for showing maps, doing things like routing and navigation. BB Cascades Multimedia has UI elements for accessing the camera and barcode detection. BB Cascades Pickers has UI elements for selecting for picking a file or picking a contact, for instance. And BB Cascades Places, this is kind of that replacement that I mentioned for the Landmarks API from Qt Location. So what do APIs in the Cascades framework look like? Well, we build on Qt, so we try and look like Qt when we can. We try and follow Qt conventions as whenever possible. There are a few notable exceptions. For instance, we don't prefix all of our classes and functions with Q. Instead, we use namespaces. And if you saw those previous slides, you probably guessed that we were using namespaces with the colon. Uh, we use the virtual keyword whenever we override a method in all the subclasses. Many of our enums live in their own standalone classes, just to make referencing them a little bit nicer from QML. And we use the builder pattern in a few places. This is primarily for UI construction in C++, but it is optional. You can still use kind of a property-based API if you choose to. We also want to expose as many of our APIs to QML as possible. We recognize that we want to give people choice, and if someone wants to have more of their UI logic in QML, power to you. So whenever possible, we've tried to expose APIs to QML. And we also have kind of this naming convention which we follow throughout our code. So given a particular namespace like bbdata, that lives in a library called libbbdata. And then the include path for the headers in that library are, for instance, bbdata would be bb/data/class name. And we use extensionless headers just like Qt does for all of its classes. So here's an example. This is the SD card info class from bbdevice library. And let's just quickly take a look at it and reassure you that yes, it looks like your regular old Qt API. So first of all, we've got an include. Again, we're following that pattern where SD card state is in the bbdevice namespace, so it's bb/device/class name. Again, we're using namespaces, so everything is going to be wrapped outermost in BB, and then the innermost one will be, whatever particular module it is. Most of our classes are Q objects. So, for instance, we use the parent-child relationship for managing object lifetimes. So that shouldn't be any surprise to Qt developers. Here we're using the virtual keyword when we're overriding a method. This is one place where we deviate a little bit from Qt conventions. We're using pointer to implementation, the pimple pattern, just like all the other Qt classes for binary compatibility. And this particular class has two pieces of state that it deals with, one called state, which is basically, do I have an SD card inserted or not? And then activity, which is like, is the SD card busy? Are you reading and writing to it at the moment, or is it idle? And we have signals for when those change. And we expose them as Q properties so that you can use this class from QML. And you might have noticed that the types look a little bit weird in that they're fully qualified. And this was done to kind of work around a limitation in mock because mock doesn't deal well with namespaces. So if you're interested in learning more, we have a booth in the exhibitors hall that you can stop by and talk to any of us. You can also go online and visit our developer website. We have lots of documentation up there, API reference for all of the libraries I mentioned. We have user guides. You can also download a number of very cool sample apps that the team in Sweden put together. They're a little bit quirky, some of them. Pull my beard. You can download our SDK, which comes with all the libraries and headers and tool chain, and it comes with an Eclipse-based IDE called Momentix. You can also use Qt Creator. There's a plugin that we have available for that, but you'll need to have the SDK installed in order to use Qt Creator. We also have a simulator available. We use VMware, so we have a VMware image that you can download, and our SDK runs on Mac, Windows, and Linux. And also, you can use that dev alpha device to test your application. We have a couple of them available at our booth. So if you stop by and talk to the dev relations people, you might be able to get one. So let's talk a little bit about the future. So what are we working on? So if you're interested to know what's coming with the Cascades framework, we have our roadmap available on our website. We're kind of using this kind of cool flight arrivals format. where you can see the different features that are coming, different APIs that are coming, the release they're scheduled for, the date of that release, and their status, whether they're on time or whether they've been delayed and pushed back to the next release. So RIM has been using Qt for a little over a year now, and a lot of different teams within RIM have been using Qt, and there's a lot to like about Qt. I don't think we could have gotten as far in our development as fast as we did without standing on the shoulders of all the great work that Qt has done. But obviously, having used Qt for a while, we have some ideas too on how things could be made a little bit better. So here's kind of a high-level list of just, not exhaustive, but just a few kind of key points of how maybe we could improve things. So first of all, we'd like to see the dependency on Qt GUI minimized, obviously, because we have an alternative UI stack. So if possible, we'd like to see if there's a library that contains UI-related APIs and non-UI-related APIs, we'd like to see that maybe split in two different libraries. There are also some low-level classes in Qt GUI, like QImage, QColor, QVector, that we'd like to see moved out so that we could use them in Cascades. And some of these points may already be addressed in Qt 5. We'd also like to see doing QML bindings made a little bit easier, because we said that we try to expose, well, obviously all of the UI stuff is exposed to QML, but also many of the non-UI APIs we try to expose to QML. And there's a few rough spots there that we feel could be smoothed out. So for instance, we'd like support for exposing custom value types to QML, or maybe doing like a dynamic handling of property queries and setting, kind of the way that QVariant map exposes the keys of the dictionary to QML. It'd be nice that if we could leverage that support other places. I already mentioned one of the problems with mock is that mock doesn't deal well with namespaces. Mock also doesn't let you have templated classes that are QObjects. It also doesn't let you have nested classes if the inner class is a QObject. So any improvements to mock would be awesome. Having looked at in our port a number of the different ways in which Qt integrates with the host operating system, there appear to be several different strategies for how you abstract the underlying platform, and we'd like to see kind of a single strategy applied everywhere. We think that the plugin-based architecture is probably the way to go, kind of what was done with QPA, so it'd be nice to see that applied over a wider area. And finally, we'd like to see the Qt libraries kept be small and focused. So have them do one or two tasks and do them well, and broken up into multiple libraries if you've got something that's really too big. Simply because we're running on mobile devices which may not be as powerful as your desktop machine. And so if we have an application that needs an API and has to load a giant library to memory, and the vast majority of it isn't used, that's kind of a waste of space. So where does RIM go from here? Well, number one priority for us right now is getting BlackBerry 10 out the door. Everyone is heads down working on that. Once that's done, I think there will be a lot more breathing room for everyone within RIM, and we can start thinking about, what are we going to do next? We can definitely start thinking about Qt 5, investigating all the cool new things that it has available, start planning our transition to Qt 5. We want to engage more with the Qt community. That's why we have a presence here at the conference. But this also means that getting more teams within RIM, kind of connecting them with members of the Qt community, monitoring the mailing list, participating in the mailing list, forums and things like that. All of the changes I mentioned for our BlackBerry port have been upstream, so RIM has been making commits, and I was actually surprised to see us listed as one of the top committers for Qt, but I imagine most of that work has probably been on our port of Qt. We need to, I think, branch out and start making contributions to Qt that many other platforms can also benefit from. So we need to kind of put our money where our mouth is, or our code where our mouth is, so to speak, and back up our suggestions with actual patches. And then because Qt is now such a critical piece within the BlackBerry 10 platform. We have a deeply vested interest in seeing it succeed and seeing it grow and flourish. So we need to, instead of sitting back, need to play an active role in seeing that happen. So that's it. Are there any questions?